Hello, welcome to the stream. Starting up now, trying to get my stuff in order. So hi, welcome. What do we have today? Yes, I'm a little bit disorganized right now. I'm gonna start slow with coffee. I just got a refill. So morning everyone. It's I figure today it'll be roughly 2 hours of merging PRs, right, and PRs for the website as well. And then I have a little idea of a feature I wanted to. Someone reminded me of a feature I actually suggested in the past. So I figured maybe I could take a stab at that. And that is adding variables to the -w function that could output parts of the URL so that you can use curl as a sort of a URL parser, output parts of the URL, sort of split it up into components. If you want to, I'm going to experiment a little bit with that. I'm not sure exactly where I'm going to go with it. I can show you. Someone actually reminded me that I actually posted this email back in 2018. So 4.5 years ago, I proposed that idea. So I'm thinking maybe I'll try to maybe add a bunch of variables for adding parts of the URL. Well, I've also actually considered adding a long time ago, at least. I thought about embedding a programming language into the curl tool to make it more of a, so that you could do more libcurly things in the curl tool. But I think pretty much when we added the --next option, I also took away some of the sort of the reason to do Lua things. But okay, could still be. So I wanted to go over to, wait a minute, where's my browser? I'm going to go to the GitHub curl pull requests. I would imagine that today in the current world, people would prefer JavaScript to Lua, probably. But JavaScript is a monster, so I really don't want any programming language anyway, because it would bloat it and complicates things so much. So nah, I'm saving that for another anniversary. I'm going to. I created a few pull requests myself the other day, and they are. Oh, look at that! I have many. Well, we can ignore these 3 ones, I think. This one is for debugging only. It's just a draft. The converting it replaces another realloc code path to use dinbuff instead, which is good. But we have another PR in the same function, and I I think I will merge that PR first, and then I'll redo my PR instead of the other way around, because otherwise I will destroy his PR. And I think I said he. I don't know if it's a him. But anyway, I will destroy the other PR, and I think that's just unnecessary. I think I can do that extra work instead. And then I did a indent fix on the entire OpenSSL code. And there's another OpenSSL patch, so maybe I can merge this one. It's actually pretty big, because it's 300 lines that were so so annoying. I changed indentation of a line, and then I get static code analyzer warnings. But anyway, as you can see, the 300 lines modified, but they're all just white space edits. It looks like this. If I look at the diff, you can see like this. Basically just adjustments of silly things, moving them around horizontally. I think because it has been edited a lot over time by a lot of users, and we have not always paid a lot of attention on the indentation. But I figured I could clean that up as a single fix. So maybe I can just merge that one as a soft start. And then like this, let's rebase it, and I update the description. Close is 10.840. I can merge this into master and push it. Push, and delete the branch. There. Then we have that merged. Fine. Back in Firefox land, we delete the branch from there, and we're done with that. And back to my list of stuff. If I reload that one just disappears. And then I did one of these. Here's another cleanup of code. And this one is, first, of course, it has a lot of failed CI jobs, but these are, I checked them this morning. So this one and this one, there are false, or, I mean, they're flaky errors. They're not caused by this PR really. And then we have the sort of the regular flaky builds, and they are the Windows AppWeyer ones. I also checked those before. They actually look like this. If I check them at AppWeyer, you can see that 1 out of 1574 failed and 1 out of 1571 failed. And they are also, unfortunately, classical flaky tests. So they actually look like this. Bam. Test 1391 failed. So 1391. Oh, that's an FTP test. Kind of annoying, but okay. So this commit in the or this PR is that there's this FTP list parser, which is the functionality in curl that allows. It's actually a very rarely used feature. It actually parses a list. It allows you to download or do things with wildcards from an FTP directory. So you can basically, for example, match, files with a wildcard and act on those files. So you can basically download files that match a pattern if you want to. And this function, it had, or this code actually had at least 2 problems. First, I'll show you in my editor here. One of the silly problems, and this is of course an old problem that I just never have gotten around to fix. So this is the public header file this is the curl.h file. So this is public stuff. So this is a struct that this function can provide in a callback. This is info about each file then that it parses in the listings, right? So it makes a directory listing and then iterates over the directory listing, and it gives a callback to the user with information about each file. So this is information, right? File name, file type, time, permission, user ID, group ID, and stuff like that. And then it has these nasty things used internally. I can't remember this is not code written by me from the beginning, but I don't remember why I allowed this from the beginning. But anyway, this is so that this is library private data that is exposed in the public struct just because of, I guess, some laziness or inability to do it in a better way. But anyway, I dislike this because it allows the user to pretty much, fiddle with these, and then it'll destroy whatever the libcurl does, or something else. So it felt bad to have them here. So once I sort of realized this a while ago, it's been nagging in the back of my head. So I went ahead and did a change that makes curl not use these ones. They will all just be blank, so nulls and zeros here. And instead move that functionality sort of into curl, which also makes curl sort of, then we get a better freedom to change things better internally however we want without these ones having to be any particular value. And when I did that, I also realized that the list parser used a custom realloc. And I mentioned it before on my streams that we don't like reallocs. We want to use our generic dynamic buffers, the dinbuff system in curl. So therefore, I did that first change to move out the private struct fields from that data. I then made a general thing for the parser so that I changed a bunch of comparisons to instead use the macro isDigit. It's just a macro to check if the current byte is a ASCII number, right, from 0 to 9. One of those. Is it one of those, or is it not one of those? Because it had, I think, 3 places it did ifs instead. It's much better to use the common macro for this. And then I wrote code that replaces the realloc code with the dynamic buffer, the dinbuff. It actually, so if you just look at that particular change, it looks like this. So instead of this malloc and then realloc down here, we just add stuff to the dinbuff instead, and of course handle errors. But in general, and then I had to just map all of that to the new setup. So blah 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 blah. In general, then we actually with this improvement we actually lose 10 lines of code. So I think in general it's pretty good. And then when I had done that, I realized that I got a scan build warning because I assigned a variable to 0, which apparently was not read again until it loops and it's assigned again. So I could just remove those assigns and fix the warnings. And last night I also made sure, so this now creates a dinbuff per line of entry in the directory listing. So it'll just add all the bytes one by one to buffer. And we only allow the buffer up to 10K now. So only 10K each directory listing line in the FTP directory listing can only be 10K. And if it's bigger, this will return an error. Because if it's bigger than 10K for a single line, it's suspicious and probably something went really wrong. So anyway, I consider these 7 failure CI problems not okay, but they're not there due to this PR. Yeah, you can have long file names. I mean, this should could be then handle file names up to like 9.9K or so. I challenge you to find an FTP server that will deliver you that long names. Those. Fortunately, we do have test cases for most of this, so I could actually make sure that this actually still works. So I'm just going to fix up these so that they are now down to well, it could have been. Actually, I mean, I should do a test case that has a file name that is that long to see that it actually catches that problem. But fortunately, when we use the dinbuff system, we know that we have test cases and we're using dinbuff everywhere, so we can be reliably sure that the dinbuff concept actually works. But testing and testing the error cases, we also test them actually because we do the torture tests, so we can be fairly sure that we can actually handle the error cases there too. Because running into that limit of 10k is going to look exactly the same as running into a out of memory situation for the cleanup exit path code. So we're down to these 3 separate commits, and I'm going to keep them as these 3 separate commits because I think that makes sense. So I'm going to merge that branch into master, and they all closes the same PR. And I do this basically because I like well, I'll show you later, but my release notes script, it'll find them, so it'll then create all of these as separate entries, and they will all get links properly. So it's a little bit of a cheat, but I think it works fine. I would imagine that if you go UTF-8 emojis, I think you will break FTP servers in general anyway. FTP is not a very good. I mean, I would imagine that UTF-8 in general can break FTP, or it might work. I don't know. It's FTP was created in simpler times, so I would imagine. I guess you have problems if you go anything beyond plain old ASCII on FTP, but I'm guessing. I actually don't know. So I merged this one as well. So reload, and now that's gone. Now we're down to 4. So I'm skipping these 2 ones, and 2 left then. And here's one. Well, we don't support ebcdic anymore. We removed that support a while ago, right? So we don't have to do the ebcdic. Fortunately, that was it causes so much pain to support it. This is a fun change, and look, Jay approved it a while ago. So back again to the dinbuff system. So dinbuff has become our generic. Well, it is our generic dynamic buffer system. So it's a set of functions to handle a buffer that can grow and shrink, and you can set contents and add contents to it, and it'll just manage that buffer for us. So the idea being that we should avoid doing reallocs pretty much everywhere. We should only use dinbuff because the dinbuff system is tested and proven to work. So as long as we use the dinbuffs, we know that it'll handle growing buffers in a safe and proper way. But well, it struck me when I read the code the other day. Was it yesterday? The day before? I don't remember exactly when. It doesn't really matter. But the dinbuff code looks like this. It's actually pretty simple, but I'll show you what I realized. So when we add data to the dinbuff buffer, we can add them in a few different ways, but they all ultimately end up calling this function, append n number of bytes to the buffer. Here's the data, here's the size of the new piece that it appends to the end. So anyway, so if it has too little memory allocated, it will double and try again, right? And it'll double until it has enough, until the allocated amount fits what it needs to fit, right? So that's why it loops here. If the allocated amount is less than what it wants to fit, double the allocated amount. So, because we double it so that we don't have to increase it so often, because it's just an optimization instead of just adding it to fit and a little bit more, because sometimes we add 1 byte at a time, right? So we don't want to just add 1 byte to the realloc, because that would make a lot of reallocs. So anyway, we do it like this. But then it struck me that we have this system for every dinbuff. We also set the too big field, which is a way to make sure that all dinbuffs we have in curl, they all have a fixed maximum number of bytes that we allow it to grow to, and if it grows larger, that's an error, and it'll return error for that. Pretty much as a way to detect errors, mistakes, or malicious behavior somewhere. So it's more of a safety measure, or so if things go wrong, it'll hit that boundary and it'll just return, instead of ballooning up to an insane amount of memory and then causing some other problems because it'll wrap a counter somewhere or something. Anyway, so if you set the too big limit to something like, I don't know, if you set it, for example, to 100k exactly, or 100,000, if to speak plain numbers, right? But since we do this doubling of allocation memory, we could easily end up like, if 64k is not enough, it would double it to 128k, right? But too big could be set to 100k. That would mean that this little loop here would allocate 28k that can never be used, because 28k would go beyond the too big amount. Basically, we would just waste a big chunk of memory that can never be used because we have another limit that says we can't use that much. It just struck me when I read this code that, wow, wait a minute. So in cases when these chunks grow big, we will also lose a lot of just wasted memory. I'm not sure exactly how much or how common this is. I tried to do some normal use cases and measure it, and I actually didn't measure much of a loss. but anyway, even if I couldn't measure a real loss, but I have this script. I call it count mallocs. So this is just one of my test cases. It just downloads 512 megabytes from localhost. So in this case, I just ran this, fixed this problem, and ran it again, and it allocated the exact number of bytes twice. So in a normal case, I guess it never really hits this, but it just felt wrong, and it's clearly a case that we can gain memory. Yes, but that is 512 megs here. It's just a test file. It's just, I mean, it doesn't really matter. It actually doesn't. I could do 512 gigs as well. It doesn't add more allocations there. It's just a way for me to, so I do this. Boom. And then it says, okay, I did 103 allocations, and the maximum memory it allocated was this. Oh, right, this only shows maximum number, right? So that's the peak amount. Or okay, it shows total too. So anyway, so it shows to do 500 meg downloads, it allocates 103 times that's the total amount of memory. And then, so I fixed this little problem, and so it just downloads the 512 megs and throws it away. It doesn't even save it anywhere. It's just to as a way to just count number of mallocs. So anyway, so I did this little patch. I can show you. It's very simple. So basically, and it also struck me that if you set the too big number very low, like if you only want it to be 10 bytes, then and this min first alloc is actually the minimum alloc it will do is set to 32, And then you could get the same problem for a very, very tiny alloc as well, because it doesn't make sense to alloc 32 bytes if it's actually not allowed to be bigger than 10 bytes. And we actually have one of these cases, so I ran into this thing. So it could also then shrink it even more for the tiniest allocations, and I set the maximum here. If it doubles up to until it's larger than the fit, but if allocating the allocated amount is then larger than the too big, it can just set it down to the too big value. Basically, in my example with 100 and 128k, if the maximum is 100k and we get the A up to 128, if that is larger than 100, we can just set 100 instead, and we would save 28k in the allocation. A very tiny fix. Won't change much in the greater scheme of things, but it feels right, and it is right, I think. So that's this PR. So here I am. And this text, or the commit message, actually explains then what basically I've been saying here. A tiny change, and since this changes the dinbuff system, and the dinbuff is used literally everywhere in libcurl, so we can be pretty sure that we at least didn't break anything horribly, because we're using dinbuff in, I think a majority of all the allocations these days are made by the dinbuff system. So just a good, better memory use. So I push that, and let's delete the local branch, and over here it is now closed. Let's reload that page. Yes, it's closed. Delete the branch there as well. And we are down to 3 open PRs. And we're ignoring the 2 bottom ones. And someone, or actually Harry Sintonen, pointed out to me yesterday evening that, this document, HTTP cookies, it explains a little bit about cookies. Surprise. And it actually didn't mention the HTTP only prefix. And it's a bit of a weird one. So when we store cookies in a file, we call that the cookie jar, right? And the cookie jar uses a file format that was actually created back in 20 years ago, right? It was created by some browser. I think I'm not sure exactly which browser, but I know that Firefox used this format 20 years ago. So it's not that we invented it. We made sure that we interoperated with that file format that was used by the browsers back then. Of course, no browser is still using this file format, but we are. So we stick to that file format. So anyway, the file format is odd, and it uses, it's a single cookie. Each line is a single cookie. So if you have 100 cookies, there will be 100 lines, and typically all lines that start with these hash signs, right? This one is a comment. So if you start that line with a hash sign, it's a comment, except lines that start with this, so hash and HTTP only underscore, which is really weird. We didn't invent this. The Firefox people, I think, did it, because HTTP only is a weird option setting config thing that you can set per cookie from a server side. And this is the way they decided to mark that for cookies in the cookie file. So if the comment is not just a comment, but if it starts with this, it's not a comment, it's a genuine cookie. So the rest of the line is then a cookie line. It just starts with this. So, but the point here being, we've supported this for, I don't know, 15 years, but it wasn't documented in this file. This file documents the cookies, and this particular feature then lines that start with that or hashes are treated as comments, right? Pound signs, hashes, whatever you want to call it. And exceptions is lines that start with HTTP only, which is a prefix for cookies that have the HTTP only attribute set. That's, my tiny little addition to just explain this little thing, because you might see these lines in a cookie jar when you tell curl to save. And no, you don't see this in dark mode, and in particular because it's very bright here, so I wouldn't use dark mode. I actually rarely use dark mode in general, but I certainly don't do it when it's very bright. I'm a fan of dark text on lighter backgrounds like this. Also, I'm old. I'm accustomed to my old ways. So I'm sticking to my old ways. I'm sticking to. Okay, so this is a very basic PR, of course. So I'm just going to go ahead and merge this one as well, because seems straightforward. Jay approved it, and I mean it's not much to talk about, right? It was just an omission to begin with. It should have been described from the beginning, and now it is described. So look, I forgot to delete this branch. So I'm going to merge the HTTP only branch into master and push it. Boom. And I delete the branch, and I delete the branch on GitHub as well. And now you don't see this, but now I don't have any more pending PRs that I have authored to deal with. Sometimes I also go ahead and prune some of those dead branches, removed branches now. Since I've deleted them locally, I've deleted them remotely, so I can prune them. And the reason I do this is just so that if we go here, if we check the code on GitHub, so the number of branches here, they don't just go totally bananas. Sometimes I've forgotten to delete some of them, so then I can go here and delete those. I also have a bunch of branches that I want to have to remain. But okay. My tiny curl branches, for example, they can probably, I think they should survive. I have this ignore custom request on a redir thing that I want to have there. Time added is my debug thing. OTSP take 2 is my other thing, so I can leave them there. Right, so here we are with other PRs then. So I fixed mine once. And okay, of course I know my own ones the most, but okay, there are other. And I figured this one was a great addition. First time contributor from Ronan Pigot. And of course, this points out a mistake in the documentation. For the config option, it just documents where it finds the curl RC file, and then actually points out that it shouldn't be the dot in there, it's actually dotless here. Yes, I am related with curl. It's my baby. Can you be related to a software project? Anyway, so I'm going to go ahead and merge this because I think it's fine. It removes a single dot, but it's improvement. So I'm just going to merge that, rebase it with, and make sure that I close the correct PR. So 10849. And it looks like he has a proper name there as well. Yep. So, and when I merge someone else's code, I try to also say thank you, because someone has actually taken their time and effort and like in this case actually contributed their first commit to curl. So now since we know that this was a first time committer, right? So this was the first time this person committed to curl. So now we can actually just check with this script. So now we are 1126 authors. Usually I send out a tweet also and say thank you, welcome to the team. I'll do that, but I don't want to do that in the live stream because I don't want to go do that here because I don't have that set up on the screen here. I'll do it later. So now we are 1126 authors in the curl project. This script, this particular script that I call delta, it shows the delta changes since the most recent release tag. So since this tag, and here's the date of that particular tag, this has happened basically. So it's been 7.8 days, and this is the total number of days since the first curl release. So we're at 9,139 days since the first curl release. So this is the number of commits since the release and so on. So yes, this is all C89, and you usually then anyone who actually works with C in general tend to then come and ask, wait a minute, what can't we do at least C99, and then we can start a discussion. So yes, we have the discussion every now and then. Should we bump the requirements to C99? Maybe we should one day. We have not done it so far. One of the challenges with going C99 is that it's harder to maintain some of the checks and boundaries that we still want, because there are still stuff in C99 that is not implemented by all compilers, and maybe things in C99 that we don't want to use. So if we want to go C99, we might not go all the way, everything in C99, and that's harder to verify and check that we still do things correctly. So I don't know. That's one of the reasons, at least, and the other reasons, of course, being that there's no strong incentive or reason for us to go C99. But you know, curl is C code. We use any compiler you can use. You can compile curl on anything you want. So whatever compiler you have that's C99 or better, you can compile curl with. So on Windows, use whatever compiler you want that's C89. That's usually, you know, MingW, it's Cygwin, it's Visual C, it's maybe not that many different more compilers these days. Sure, you can ask, but I don't. There's no reason for us to bump the requirements to go crazy. Quite the contrary, I actually see very little reason for us. I mean, even C99 have just. I mean, sure, there are some stuff in C99 that would be cool to support, but beyond C99, I don't even know a single feature that we want. So I think we're far away from going beyond. I mean, we're not even on C99, so going beyond that, I think we're even further away from. At least that's just my feeling. Well, the internet, everything runs on. I mean, everything low level enough is C, right? The kernels are C. Almost all system libraries are C. So it's not just the internet, it's everything runs on C. Then when you there are coming C alternatives. So sure, in the future we might see other things than C. But yeah, nowadays it's sure C++, but you don't see any low level stuff. You don't see kernels, you don't see system libraries written in C++. You see C++ used in browsers and other application. Okay, some system libraries perhaps like Qt and stuff like that, if you call that system library. Yeah. Yeah, maybe the system, the Windows kernel is C++. I don't know. So yeah, sure. I'm sure that there are kernel things in C++ anyway. So yeah. So where was I? So I merged that pull request. So now we're down to 52 pull requests open. Skip malformed RTSP into leave frame data. Yeah, so this is this PR that we've been reviewing and talking about before. I want to see how it goes. Yes, 9 failing. That's an unusually large amount. AppWare. Only Windows fails, but two fail in 1 hour. Yeah, so we're starting to run into this 1 hour limit on AppWare, which is annoying. So the hostname dev23 is just me not having imaginations. It's my new dev machine for this year. So I actually changed, since I had another hostname on my old machine, and I needed a new hostname to just see the difference from the old machine to the new machine. So this is the dev23 machine. So this is actually a recently purchased upgraded machine. So it's a pretty speedy one. So I hope I don't plan on upgrading my machine now again for a bunch of years. So that's so dev23 short enough to work for me. So yes, so this is my actually local username, and this is the machine name, and this is then my local directory, and here's the Git branch. So I like having the Git branch in here in the prompt, because I have a lot of, if I check out, I have a lot of local branches, Git branches. So a lot of it. Many of these, of course, are just branches that I forgot to delete, so they're just sitting there. I should delete a bunch of them, but yeah. At the same time, they're very cheap to just have there. Okay, so right, I wanted to. So let's do this. We have. Oops, I I managed to press the key with the wrong window in focus, and then I checked sorry, I changed the scene on OBS instead of pressing home in Firefox. Sorry. Back to, I wanted to go to Firefox. Where am I? Here. Here's Firefox. Okay, so I actually wanted to go back to GitHub and then go to the curl www repository on GitHub. Yeah, so what you see on the screen, I try to repeat this every now and then. What you see on the screen is not what I have on my screen. I have you see a bunch of selected windows that I've chosen to show you. It doesn't look like this on my screen, but they're Emacs and they're terminals. They're actually console terminals. I run KDE or Plasma as they call it these days. So I show you Firefox terminals and Emacs mostly. Right. So we're back in. I wanted to show you because this is the website repository, and the website is a weird hack. Well, the website, it looks like this, and I could probably zoom it a little bit. Anyway, so the website is created by it's pretty much the same setup that I created in the mid 1990s for other websites I did, and it's been the same setup since pretty much. And it's a static website, so we build everything. We generate HTML files on the host. It makes it really fast, and it's also easy to run your own local copy to try it out. I have actually, so if you want to develop the curl website, you can create a curl.local in your HTC hosts and point it to your directory, and then if you just agree to it not being HTTPS. So curl local. This is my local copy of this is my machine hosting this. So as you can see, it looks fairly similar to the deployed one. So it actually makes it very easy to run your own clone of the curl website. It's not an entirely identical copy, but still it makes it easy to try out things locally before pushing it to production. Anyway, so it's an old system. It is actually a bunch of files that are pre-processed with a C preprocessor. So there's a lot of defines and stuff like that in the code, and you pre-process everything. There's make files, source files, generated files, and the generated files are of course those that you see. So everything here are files generated in the build process when we build the website. So we update from source, we run make, and that make builds the website, right? I can show you how it looks like if I so I have the entire website then in this Git repository. It's up to date, and I can run make in my repo here, and it builds the website. So here, that's the website. Well, here's my local repository of the website. No changes. And over in the Git repository, it looks like this. So you can see that, for example, we have a lot of weird patches for CVEs in the root directory. I sort of regret that, but I'm going to fix that at some point in time. They can remain there for now. I mean, we pointed out them pointed to them with URLs in early CVEs, so someone is going to keep using that URL somewhere. So we're keeping them around. Anyway, so this is basically the basic setup for the website. If you want to fiddle around with the website, there's a README. Well, that's the one that's shown down here, and it actually explains what tools you need how to build it, how to run your own copy, and how possibly to use Apache HBD to host it locally. That's how I do it, like this. Anyway, so enough of that. So we got pull requests for the website then, so people are graciously helping out with fixing things. So here's Renaud Douglas found a typo in this CVE advisory. So let's take a look. Has been changed. I could have made the effective user a very different one, thus leading to doing the second transfer with the wrong credentials. Thus leading to dead. Yes, that looks like a perfect fix, because I'm a king of typos and writing things in confusing ways. So I'm going to merge his proposed fix into the Git repository. Yes, so it's compatibility. So C89 is way. I mean, maybe now we're starting to actually have C99 compilers almost everywhere, but we haven't. I mean, not even Visual Studio has been doing C99 for more than 7 years or something. I think it was 2015 or something when they finally started to do C99 somewhat. So it's not that C99 may sound old, but it's not been around for very long universally. And I'm not sure it's even universally available now. And not even, I mean, a bunch of, not even Visual Studio supports all the C99 features, right? So there's a bunch of features in C99 that are not universally available. So that is also a reason, something that makes C99 slightly more complicated to use than C89. Because we would have to ban certain parts of the. Oh, I forgot to let it run the CI jobs for this PR. They just make sure that some basic stuff seems to be okay. One of the finest features with C99 that I miss sometimes is that when you initialize a struct, you can use named struct fields instead of just assuming their positions. You know, when you, for example, initialize a struct in the beginning of a function. Yep. So the CI builds for the website are very basic. So. But this also was a very proper fix, right? So I'm just going to merge this work into here. I'm going to close this 229 type of fix by Douglas. Looks great. Push it to master. And now, so I'm pushing this little thing, and this just updates a single markdown file, right? And since I've updated it now, and I can just run make here, and it'll update the website, as you can see. Bird. For some reason, it decided to update the example page too. I don't know why, but it doesn't matter. Curl is a command line tool and a library. Well, it's curl the tool and libcurl the library, so we just carelessly call them curl, everything curl often. Curl is the project, and we make curl the command line tool and libcurl the libcurl, the library. Okay, so this is the command line that actually updated the web page for this CVE. It's a bit of a complicated thing, but the point is that it converts the markdown. And it adds some link stuff and blah, blah, blah. And then it generates the HTML page. And that's the one. And when we have pushed this to the website, actually we push it to the master branch on Git. The website automatically updates from Git, I think every 20 minutes or so. And it'll run make. So if anything has been updated, it'll run make and update it. And of course, then we have the additional thing that the website is fronted by Fastly, which is a CDN system. So, and the CDN servers themselves, they cache content, so they will keep on showing the existing page for a while until that expires, and then it'll get a refreshed copy from our server that is then updated, hopefully, and then it'll show the new content. So it's a bit of a, you know, it's not complicated, but it's a elaborate setup, and it works really well, I would say. I am in Sweden, and we got a lot of snow again today, and I think it's too late to get a lot of snow. We got like 10-15 centimeters of fresh snow. I was out shoveling the driveway this morning. And actually I have ceiling windows up here just above me. That's the light that comes from here, but it's actually the windows are all covered in snow now. But it's fairly thin, so the light is coming through. Curl is 25 years old and a little bit more, a few days. So we're actually 25 years and 8 days exactly today. So I wanted to then just continue through here, because I haven't really checked on these pull requests recently, so maybe I should. So here are more. I forgot to say thank you in the other one. Where is that? Thanks. I want to say thanks. And then we go into that one. So I just want to browse it first to see the previous flaw, blah blah blah, commas to set to severity of medium, but since this is a sure, let's agree that this is better. Approve and run. So let's so now when he's this user is no longer a first-time committer, in the future these CI jobs will actually run automatically. So it only requires permission for me to activate it as a first timer, I believe. It's, I don't know why I have that config enabled. I will probably change that. It's not that it's getting abused really. So this is basically just yes. So this is, I just need to approve it for the first timers, and this is just a formality, right? Because it's just updating a single markdown. So I'm pretty sure that, of course, the CI jobs will go through fine, because we verified it, right? So it's fine. I will just pull his work into master like this. So this is still in the website repository. We merge his branch. Let's fix up their minor. I actually like the lowercase. And this is closes 228. When I started out curl, I don't remember if I think I already switched to CVS. So by the time I did since curl started as a different tool, well, started, and I renamed it once, and then I renamed it again to curl, but it existed before it was curl. So I started RCS, and then I switched to CVS sometime in 1997. So by the time I did curl, it was already CVS. And then we stuck to CVS until 2010 when we switched to Git. So we never took the subversion step because I didn't really felt the need. So I'm going to push this to master. And in the meantime, the CI jobs went through fine here, of course, as expected. And I'm going to say thank you for that excellent fix. And now we're down to 4 pull requests. And what is nice now, I'll show you a fun little thing. So now we got these 2 new commits in the website repository, and I also edited it myself the other day, and you can see I fixed some other stuff like this, blah blah blah. And what is fun is that when we then go to the regular source code directory, we can run this script to figure out who are the contributors who have helped out with stuff since the previous release. Boom. And now it finds who did this, Douglas R. Reno, who actually did those things in the website directory. So they are also then counted as a contributor to this new version of curl, which is fun. I should probably, so I try to update the release notes every now and then, just to make sure that it's roughly in sync with what has happened recently. So this is the release notes. I updated it 4 days ago, well, March 24, and now it's 28, so it's been 4 days. So I can probably update it again. I run this script, and then it has updated my release notes, and then basically I go through and delete those lines that I think are not worthy of being mentioned in the change log. For example, I don't think use isDigit digit needs to be there. I don't think we need to have that one. Timeout. We can have release procedure. We can have that one. Fix typo. Maybe we can remove that one. Yeah, I think like that. And then I remove that line because, and then we have this little fun thing, clean up, and now it has sorted all the entries and removed dead references that maybe I removed there. So now it's updated, and then I run this script, contributors, to make sure that so in the last 4 days we have added 10 new contributors. So now these 70 people have helped up. And then I usually check out the numbers at the top as well, because another script then. So we're at 2845 contributors. It says so here. Contributors being anyone that has gotten credit anywhere. So that includes people that have reported bugs or helped out in other ways. So since we try to, like this, reported by, or sometimes we have, we can assisted by, we can do all sorts of things here, assisted by, we can add whatever by credits in the Git commit messages, and the script will find those names and include them in this output, and then we put them in the release notes and we say thank you. So, and also now this script delta it actually counts the number of lines here, because these are then considered bug fixes, right? So now it says 27 bug fixes logged. In 7.8 days. So this is the difference from Yep, looks good. And the key then is to use this this magic git commit message is synced here, and that's the keyword that my scripts are using, so that it knows at which point in time I did this update the previous time. So basically we just do this, because then my script knows that this is the time we synced the release notes. Curl started out not at all on Linux. I was not using Linux much in 1996. I was playing with a lot of other Unixes, so I think I started using Linux maybe at the time I started shipping curl, somewhere in 1998, 99, something. That's when I started playing with Linux for real. So, but by then it already existed, and it already built on a number of different Unixes. So it is actually, I mean, I think maybe Sun OS and Solaris were the first Unixes that I did it for. But by the time we shipped curl, it built on all those Unixes that were around, that were big at the time at least. Well, I would challenge anyone to make the release notes better or faster than. I don't consider this being a manual way to do it. I mean, as you could see, I generate all this with scripts. So I still need it. I mean, of course, we can probably improve the way of doing them, but they still need to be curated and polished by hand. So you could possibly consider doing it on some kind of webby thing. I really don't like how. I mean, I know there's some ways to do it on GitHub itself, but yeah, it's not better than this, I think. I'm pretty happy with this way of doing it, and since it's all then integrated, so I can count the number of bugs, and this then also gets converted very easily, so that when I've done this push, it's also updated. So if I go to the website, and if maybe I check the one that is actually live and not my local, I can go to, for example, the release notes, and this is the web version. This is the older version, the previous version one on the web. Then if I reload it, well, it hasn't been updated yet, so it's still the old one on the website. But in a few minutes, an hour, this will have updated to the latest one, right? Because and as you can see, all of these changelog items are then proper links. So if you actually want to, wait a minute, what do you mean with setting SO name for Sun OS? What kind of change was that? And you can actually click this, and you can read about it, because here's the patch that actually did this. So okay, what do you mean? So this was the patch that actually fixed that. So it's all a sort of an integrated system here. So it's everything standalone might be silly or pointless or something, but I think everything is tied together here, so that whatever we do. So that's also the reason why I try to sync this every once in a while, right? Because it gets updated here on the website. Let me just try to force that and see if we can. So anyone who wants to keep up with what we're doing can just wrong page. I wanted to go back to the release notes and reload. There, that's the new one because I forced it to happen. So that now you can see I pushed that update to the website, and wow, now it's updated on the website. So now we have all those 27. These are 27, and presumably I don't want to count. 27 fixes. So now they're all. So anyone who wants to keep up what we're doing in the project can just reload this page every once in a while, and you can follow along. Or you can just look at the the release notes in Git, of course. And then yes, so since the release notes in Git and this page, they're roughly kept up to sync. I sync them every 7 days, and then it makes it easier because at the time I make a release, they're almost in sync, right? I just have to make this final sync, the last few days, make sure they're in the list. They get rendered on the website. I can put together a release with its release notes quite easily because I'm always pretty much up to speed with how things are. So doing the release notes is at least a part of the release is not a lot of work, since at least that's the final thing. Well, that sure. For the docs, sure, we have a lot of different frameworks, but then we need to remember that, of course, we don't use any modern things because we've done docs for 25 years. So a lot of our stuff is built on foundations and procedures we started a very long time ago. So we don't we could imagine switching to newer frameworks and newer fancy things, but I think our setup works really well. And of course, I'm an old Unixy guy, so I for example, I want man pages for everything. So I have man pages. So I'm making sure that everything we do are available at the command line, right? So I want it to be. I want you to be able to have curl, and you can figure out, how do you do curl easy perform when you sit on your plane. I don't have the documentation installed. Why? Okay. Last example, right? So I wanted to be available at the command line like this. So of course I want everything documented to be available as command line. So that's why we have everything as man pages. So I need the documentation to not only be available as command lines, but I also want them to be available on the website. So we have a system that generates the man pages on the website. So that's why if you go to the website and if you want to check the same function, right, you can for example, you can go and check the API, and then the API overview, perhaps, blah blah blah, the curl easy perform. So therefore our man pages are rendered as the web pages like this, and everything is of course then linked properly, they link to other man pages, and we have I think 486 man pages now. And we actually have a very strict checks now that we have every man page has to have name, synopsis, description, example, availability, and all these sections in the same order, and they all have to do them. And possibly example could be the most important part. So we make sure that all our man pages these days, they have examples, so that to help users more. So a lot of these, of course, handcrafted ways to do things. So we have a lot of docs, and I think a pretty good system to handle them. And it works, I think. One of the best things with our docs, I'd say, is that we don't break APIs and we don't break behaviors. So whatever we documented a long time ago still works. So it also allows us to work and polish and improve things over time quite a lot. So this particular man page, for example, this function, this was created in the summer 2000, right? I invented this function name and how it works. So this description and everything, we can work on it, polish it, and it remains there, right? So it works the same way, documented the same way. Well, we can improve the documentation over time at least, and it's still, and when we improve it, it also improves how it actually did work back in the day. So, and I think that's one of the things that make our documentation really good. That it just we've allowed everything to just improve over time. So by now, most stuff is documented pretty good. And of course, we have a lot of tests and cross checks and everything, that everything is there. If we have a list of stuff, we verify that in tests so that they all reference and that all references work and that we have everything mentioned everywhere, every function is. So yes, we have a lot of elaborate setups to make sure that we don't even allow, you can't even do bad links in here because we have tests that will verify that. We actually even verify the prose for the English in the documentation. We do spell checks. We do quite a lot of tests and CI stuff to verify that the documentation is up to snuff. Of course, it never is, because we still have problems, right? Or we still forgot to say things. We still forgot a lot of. So you can still continue to find problems and report bugs, but if you ever read our docs, you should. I think that you will see that we have put a lot of effort into them, and we continue to do that. And I think it's a very important part of providing something stable and for the long term, so that everything is documented to lengthy details. We both compile. We generate everything. We run a lot of tests on the documentation in the CIs. So yes, we verify everything all the time. We actually don't generate the man pages. We actually edit the man pages in nroff format, which is one of the, I would say, weak parts of the documentation systems. But still, we verify those files quite a lot, so that we check that they're. We don't run a full sort of syntax check, but we check that, for example, all the references are correct, and that. As I mentioned, we verify spelling, we verify prose, we verify a bunch of things. It's actually pretty hard to spell check a man page because this stuff, you don't want to spell check the example section, for example. So I have a pretty elaborate setup which strips out parts of the man pages before it runs the spell check on them. So it spell checks the descriptions and the return value section and a bunch of that, and it removes the synopsis and the example and stuff. But that's the man page part of everything, right? And then we have, for example, if you go to the documentation, you can see that we have a lot of other docs that are not. We did this update to the cookie documentation, right? That's a markdown file that is present in the source code tarball, pretty much. And if you go to the website, you can read the HTTP docs here, the HTTP cookie docs. This is the markdown converted to HTML and visible on the site, right? So here is I showed you before we talked about this HTTP only prefix that is available in the cookie jar. So this, we merged a PR previously, and this is how it appears on the website. So this is the markdown converted to web. for the cookie file format. So this is the thing we extended previously. So the test for the docs are then just available in the regular test suite. So they're part of the regular test. So when we go and run the test, when you run through the entire test suite, you have also done a bunch of tests on the code compared to the documentation and vice versa. So it actually, for some things it checks all these different symbols in the code or in the public headers, and then it checks that do we have documentation for all these options that is found in the headers, and vice versa. So you can't mention something in the docs that's not in the code, and you can't mention code that's not in the docs and stuff like that, to make sure that we are always in sync and hopefully not misspelled too badly. And of course, all of this sort of has grown over time. So of course we didn't have all of that from the beginning. So we slowly over time tightening the bolts and improving all these things. Yeah, so we compile the examples also in the CI. So we make sure that we have the examples split up in two different parts actually, because a bunch of the examples rely on a third-party libraries and we don't verify them in the CI. But the majority of the examples we actually build and we build them in the CI and verify that they don't generate any warnings. We don't test the examples. We don't execute them because they typically use example.com and stuff like that. But we verify that they build warning free at least. So if we happen to do a typo or something silly, they just, then we notice. Right. So maybe testing the examples would be a little bit overboard, right? Because then we would have to change the examples to use something that is more controllable. So we don't want to rely on external websites, for example. But the examples actually make sense to use external websites because they're examples. So like example.com is a great URL to use in examples. But as a test case, we probably don't want to torture example.com. So we would have to do something weird, and I don't think we need to do that. I think verifying that they build is awesome, and that's a good way to make sure that they're reasonably okay. So I wanted to check this add edit on GitHub link. It's proposing to add on the markdown. It's a bit crude to do it like this, of course. So one of my favorite things I'll show you if you go to if you want to learn about an option in libcurl, you go to the API and you can go and well, first the example, we talked about examples, so you can go to the examples. We have I think there are about 100 examples here, so you can go and see how to do let's do something basic, HTTP3. So here are HTTP3, an HTTP3 example. I recently added this notice. It basically says, sure, this example might not check return. Look at this, it doesn't check the return code. It can actually fail, so you should check that. But anyway, so these are all linkified, right? So in the example, all these function calls are links to the man pages for particular functions and a particular option. So here's the HTTP3 example. Here's a very basic way to do an HTTP 3 call, right? So, oh, wait a minute, this sets the HTTP version. So you want to check, oh, I want to read up about this option. So that's why we have many man pages, right? Because every curl easy setup option has its own man page. So here you can read about it. You can set different versions, blah, 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 and all of this. And then we have this one. If you find a problem in here, it's a typo somewhere, you can just hit this button, file a bug about this page, and it actually takes you to GitHub, and it says pre-fills a little subject for you, and you can say there is a typo on line 14, it says blah blah blah, and then you can submit a new issue. It's unfortunately a little bit too easy sometimes for people to do this, because we get a bunch of blank issue submissions. They are fairly easy to just ignore. And if you want to see this particular documentation on GitHub, you can view the man page source. It's similarly just you go to the GitHub repository for this one, and then you can see this is the man page source code that you just saw the web page version of. In case you wanted to. Boom, you don't have to. Well, if you wanted to do an HTTP request, I mean, typically if you use curl will do it as fast as it possibly can. So that's not fast enough. You usually have to do some other tricks, maybe avoid DNS, maybe do something else. But it's typically not that easy to make it faster. And I'm not saying that curl necessarily is the fastest one available at all times, but most times curl is as fast as you can do it. Yeah, the man pages have copyright notices. Everything in curl has copyright notices, because we have CI jobs that verify that we have copyright and license information for everything. So there's a clean state or known copyright and license information for every single file in the repository. To make that, of course, sort of just another thing to keep check of. So be sure that everything is correct. So you can see then if you go to here, it has this source file header. So it has a copyright and it has a license identifier, blah blah blah. The copying file in here, if you go to the root, here's the root directory of the curl repository. So yes, there's a copying file here. The copying file states the license for the everything in curl, right? So this is the curl license. But in order for everyone to know about what this license, first there are a few files that are licensed differently, and then there are a few files that are copyrighted differently. And in order for everyone to know exactly how the state is for every file, right? So if you just pick a random file anywhere here, you want to know the specific copyright and license status for it. So therefore it's important so that everything has a header which says copyright and it says license identifier. And you can find that in all files. There are a few exceptions, and they have patterns in here that actually have this file that then lists the copyright and license situations for these particular files. If they don't have it in their headers, they're listed here. So every single file has a clear copyright and license information status. And actually, if they don't, they fail a CI job and we fix it. So we can be sure that all files have a clearly stated copyright and license state. Okay. That's my local version. There's the web version. Well, the CI is fairly complex, as you can see. If you just go here in a regular pull request and we go, let's just see this one, for example. So here's a recent pull request, and in this case I think it has run 112 successful CIs. So you can see here, so CodeQL, this is a static code analyzer. There's a labeler that sets automatic labels for the issues. And then it builds Linux on Linux. It builds curl using quiche being an H3 library, and then it builds it, runs entire test suite with Valgrind, make sure that it's successful in 58 minutes, and then it builds on Linux build, and it runs torture tests. So torture tests being in way to insert errors everywhere, right? So for all fallible system functions that we can instrument, and then it builds with wolfSSL, blah blah blah, and runs all. And then here's the reuse compliant. That's the copyright license check. And then it builds on Mac OS, right? And blah blah blah, and blah 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 blah, and then all of these are different build setups. So OpenSSL 3 with Clang, another build, Mac OS torture tests, and then with Linux and memory sanitizer. Then there it runs torture tests, FTP only on Mac OS, and here it verifies the event-based API on Linux. A build with Hyper, a build with Rustls, a build using the Intel compiler, because the Intel compiler is extra picky on different things, and one without TLS and one with OpenSSL. And then there's a build with NSS, blah blah blah, and on and on and on and on and on and on, and then a bunch of different fuzzers on different things, runs for a while and just verifies that everything is still, not super broken. AppVeyor is a Windows setup, right? So it runs, I think it's almost 30 different builds for Windows. It's a little bit slow right now, but okay, come on, boom, maybe 25 then. Okay, so these are all different Windows builds. You can see the differently labeled CMake, Win build. That's a make file based build setup. So and this is of course just a single change, right? So everything this is done for all. Well, some of them are skipped, of course, because these are skipped because we had cleverly detected that if you update only this file, we don't have to run this build because that file doesn't affect this build. So that's how we can skip. That's why it's 18 skipped checks. So in this case, he has updated wolfSSL in the wolfSSL builds, and now it builds with a more recent version. So we can merge that. We are here. The jobs take, I would say it really depends. Some of them are sometimes a bit slow, but I would say the most they take like an hour or 2 or 3 maybe. Usually that's more than 1 hour, so maybe 3 hours, something like that. So usually I fire away a pull request and I go do something else for a while and fire up, and I do some new pull requests and then after a while I go back and check out the first one, and then recognized, oh, the test failures, oh, I had forgot about that, I had done a typo there, I fixed that, pushed updates, check the other ones, push update to those, and they sort of iterate over a few different ones over the day, and then I can go look at others PRs like now and merge them, and then go back and check my own later again. So I have that, juggling a lot of things at the same time, but it takes a while until they get down again, right? Yeah, typing the PR numbers are error prone, but I much more appreciate my ability to handicraft the commit messages and the contents properly. So I've never really become friends with the way to do it on GitHub. So I avoid doing it on GitHub because I think that's even more error prone. So for me, it's a bit of a trade-off. Either do it with what I consider the crappy UI on GitHub and avoid having to type the numbers, or I can craft it more properly myself and then possibly do a typo myself. But yes. Well, typically we don't care about individual commits in a PR because usually we squash a lot of things in the PRs anyway before we merge, so we don't have to make sure that they all individually build. Of course, we want them to be that. If we want to merge them as individual commits, we want them to be individually buildable. We usually don't verify that, though. That's a little bit of a flaw in the system, maybe, but it's also a little for effectiveness, and it's usually not terribly important. That I mean, sometimes possibly we could break one of the builds in the middle, one of the commits in the middle, but I think it's rare. Usually we have one commit per PR. So usually when the PR is fine, we squash all the commits, because typically what we do is that we fix the PR by doing just follow-up commits. So one commit and then fix, and then you end up with 13 different commits, but they're all then we squash them all when we merge. So if it builds fine in the end, that's the thing we merge, because that's how we keep the Git history fairly clean and linear. So yes, but it's only 3 hours if you have to wait for all of the builds, right? If you have to wait for the final build to finally go green. If you did something wrong, chances are some of the builds find that much faster than 3 hours, right? So maybe if you do something terribly bad, the first builds have found that out already within minutes. So if you go back within 20 minutes, you can be sure that you at least didn't mess up completely. So you don't have to wait 3 hours to get valuable feedback. I rarely get fixes from over email these days. I guess I get it possibly. It still happens. I still get patches, like maybe not every week, but at least several times per month I get patches over email, or I would say other mediums than someone providing it on GitHub directly. So I do make pull requests sort of on behalf of others every now and then. Well, typically when I think I've received one on Mastodon, I think so. But typically, if I don't get it, if it's not on GitHub and it's not on email, it's usually someone showing it on some paste bin somewhere, and shouldn't you do this, blah blah blah, or something, and then I just copy and paste it, and I convert it into a pull request on the behalf of someone else, and then push it as a pull request. I do that even for patches I get over email, because our CI setup is such an elaborate thing that I don't want to avoid that. So no matter how I get the patch, I still want it to become a pull request. So if someone doesn't want to submit it as a pull request, I do it on the behalf of them and make sure that it goes green in the pull request before we merge it. Now where am I? I got lost here. Yeah, I created those spell checking CI jobs also to sort of make it a little bit harder for to find spell check typos. Of course, we can still do spell check typos, because a spell checker is always a bit naive since you could just use the wrong word, right? Spelled correctly, but the wrong word. So you could still do typos. But they're rarer these days since I added the spell checking CI jobs. We don't spell check comments in source code, so we still do get some amount of typo fixes about spelling errors in comments in source code. I've actually tried to do that as CI jobs as well, but I haven't really found any awesome tools for that. There's some tool called Code Spell or something like that, but it's over ambitious, so it finds too many false positives. It also tries to do things like spell check variable names and things like that, and that's that's not what I want. I would like a tool that could only spell check the specific comments in C source code. Might be difficult too, because of all the weird words used there. Yeah, duplicated words. We find that we find some of those in the documentation since we use proselint, and I think proselint detects duplicated words to some extent. Not everyone, I think, but sometimes. I don't know. Maybe I should just write a custom duplicated word check. Anyway, I don't think we have too many of those. So I wanted to go back to. I actually wanted to stop this at 12 o'clock, so there's only 20 minutes left. But my thinking, I started up mentioning that I had a feature in mind where I want to see if I can extend the write out function to do output parts. Basically, if I could perhaps use curl as a URL parser, basically pass a URL to curl and ask curl to output a part of that URL to help, like my shell script. If I want my shell script to accept a URL as an argument and output the host name from the URL, how would I do that? Doing that in a typical shell script is really complicated because URLs are complicated, but curl is there and it has a URL parser, so maybe we could give curl the ability to output parts, sort of the components of the URL, using this feature. So at least that's my thinking. And then I thought about it, like if I would call it like URL, I don't have to marry the name right now. So if I do, for example, let's call it URL host. I think these are, where are they? So there's the actual URL that was used. So I can so then I can do this curl, and then I can hardly remember the API myself, so I'm going to check the man page, and it has an example. So this is how I use the URL parser, pretty much. I need a URL handle, and that I create like this. And let's pretend it can't fail to start with, because then I set the URL in the URL handle, curl URL set. There's the URL, no options for now. That's the fourth argument here, that's a flag. So if I do like this, I can extract like this from the handle. I can extract the part that is curl u part host no options. It works like this. This is the concept at least, and then there should be a curl URL cleanup of the handle in the end. So this, if this works, it'll here like this. So it'll return a host pointer here. So if there is a host, we want to free it when we're done with it. But this doesn't free it, so this was leak the memory, but this is a basic so that works. So this should then, if you do this curl and we use a known URL like this, and we use URL, what did I call it? Was it a dash like this? I want this to work. Write the output somewhere else. I mean the output from the transfer. I didn't call it URL host, did I? I didn't. Because of course I typoed it. So now then, boom, yep. So that's my thing. So maybe I can also use silent there, so shut up about this progress meter. So that would then output the host name from the URL part. So my thinking was that I would create more variables like this, so that I could, for example, do this path as well, and then have a URL path, and that one would and then I would copy pretty much this and have a path instead, and then we'll call it path. And of course this still leaks memory, so this isn't really done. I'm just trying to show you the concept of my idea. So if I build this, does it work? So URL host, and then I could, if you want to know what URL path it used, it would do it like that. Path colon. And of course, if we then remove the path from there, it would still say path slash, because that's the way of the parser. And if you would use like, you know, nothing at all, it would go there. So I think this could be pretty convenient. You can see how when doing this, you might not actually want the transfer to happen, because you might just want to do the parsing of the URL. I'm not sure what to do about that exactly, but I'll ignore that for now. I still think this is kind of a fun feature. And then of course it could do all sorts of other parts, you know, all the parts from, so scheme, host, port number, path, query part, all of that. And I'm going to do that as separate variables, so that you could get all the components from the URL. The question is what I should call them. Should I call them like this? Naming. Well, if you need a longer tooth than what your instance supports, I bet my instance doesn't support it that long either. So it's a fun. What if you toot a really long one that I cannot read? So yeah, interesting. You should make it a series of toots instead. So you create some way of linking them together. So anyway, this is my idea. Of course, this is not if I would run Valgrind on this. It would say definitely lost. And if I would use leak check on this, it would identify, right? So URL get there and URL get there. So these two URL gets, they're actually leaking the memory, since I don't free this one. So I need to I can pretty much discards const qualifier. I can make it a const as well, right? And then I get that one instead, so maybe I can, you know, not the prettiest, but I think if I do that, at least it doesn't leak anything. No leak. And it still works. So I'm going to, I think I'm going to but it will work with all the URLs that curl works on, right? So if you, for example, if we remove the scheme like this, it doesn't work. Why? Oh, yeah, but it it should work, right? And it will work. It's just good question, but because here I'm actually using since I'm using the curl's URL parser, I just need to make sure that I'm giving it the right instruction. So there are flags here, so I can tell it to use what's the name of it? I can use guess scheme, for example, and that means it allows the URL to be schemeless, which is then strictly speaking not a URL. A URL cannot be schemeless. It's not a scheme anymore. So and then if I do that, it'll allow this URL, right? So it'll just, oh, there's no scheme. We pretend it is one. There is one. So when you do this, then you can also do, like this. I happen to have a host on this, so when I do this, I can do boom, and it'll just work because curl will treat this as a URL or as a working sort of quote-unquote URL. It's not a URL, but curl will deal with it as a URL. And it'll also then use a default scheme for it. So if it would output scheme here, it would say HTTP because it'll do that by default. Or it could do, like this. If we want to do IPv6, it works the same way. So it's the same. That's the host. That's the path. So it works there as well. An interesting part is rather if you do something that doesn't work. Hello. It also works because this transfer doesn't have to work. It'll still output this. This thing is output even if the transfer fails. So it certainly failed here because there's no host called hello with many L's on my host on my network. So yeah, my plan is then to output this for all. There are like 7 or 8 parts of the URLs. I figured I should do one for each, so you could do all of them, like host, port, path, scheme, blah blah blah. Because then you could do things like this, random URL, and you have your user, for example, pass this URL, and you can use curl to parse that URL and split out the components. Yeah, it would work the same way even if you do a user component, like user at or password, like this. It's the same thing. Well, it's not the same thing. It is still a URL, and the URL is still parsed by the curl URL parser, so it'll still get the host name, right? Then, or if you would add, or you could do FTP, right? It would still work. It still extracts the host name here, so it's still the same host name. So it doesn't matter what kind of, as long as the URL is parsable. So if you would do something crazy, what is crazy? Spaces. This will not be an acceptable URL, right? So, bam. right now we get a core dump. Maybe not the ideal case, but you get my point. Then of course it cannot. Then these variables would be blank. Should be blank. Oh, right, because it shouldn't set valid. So valid should only be there, right? So now with this stupid, then it showed path. How can it set the path? Interesting. Maybe that is a kind of flaw. Oh, no, it isn't, because I don't check return codes, right? So I mean, I need to clean this up a little bit and extend it and add test cases and things. So I'm going to do that and then see where we go. Maybe I could do that this afternoon. Yeah, so let me I can just take a pause now, and I'll do this afternoon. I'll kick off the stream again at like maybe on 1.5 hours, like 1:30 my time. Then I'll kick it off, and then I'll do all the variables for all and make sure that add return codes and add test cases, and it'll take me a few hours to do that. So it could be a good afternoon session. So I'll kick this off again in case you want to hang out and see some real work. And at the meantime, let's see if there's any other pull requests that arrive. Yeah, we have Frank's pull request that he just mentioned. So there's a duplicated from the value from the yes. So no, Frank, your job is to add a new CI job that would detect this kind of mistake in the future. I guess it's more difficult when it's 2 words that are duplicated instead of just 1 word. And I guess there are cases when you can legitimately duplicate a word in English, I guess. Anyway, let's do this. I think this is approved. And I'll just go ahead and say that this is going to be fine. Git rebase. Oops. Okay, that was stupid. Write out URL parts. Debug. Yeah, I'm just committing this to a branch so that I can get rid of them from the master branch. But because in the master branch I have Frank's commit, so I want to reword it because I want to do it like this. Boom. Close this 10850. Boom. And now it's merged. Thanks. So, live PR filed, live PR merged. Thanks. And 1 typo less. Yeah, there's always that challenge and you can think of that and how to do that and then convert that into a job and into a script, and then you don't want false positives because that's really annoying. So it's a challenge to make that script, but it's fun, and of course we have a lot of those, and this is basically the way how we come up with new CR and new scripts and new tests to do. And we can add, typically when I come up one of those scripts, I add them and make them into a test case, and then we make sure that that's a test case that is run then in CI jobs, so that we make sure that we catch those things going forward. But anyway, now I'm going to take off and take a lunch, and I will be back at 1:30, and then I'll do work on adding those variables for the command line tool. That could be fun. See you later. And thanks for joining and talking in the chat. This really, it makes it fun. But have a good lunch, have a coffee, have a drink. See you again soon.